A04 is going to allow us to implement two more functions in our mini library. Um, the first one is going to compare two arrays, data1, data2, of same size. Okay, we simplify a little our job here. It's going to compare them position by position. So this is the most intuitive notion of identity here that is used, which means we return 0 if every single position in both array contains the same value. Okay, so data 1 index 0 contains the same thing that data 2 index 0. Data 1 index 1 contains the same thing that data 2 index 1. Data 1 index 3 or whatever, etc. You see what I mean now. So this is the first one we're going to start by implementing. This is the easiest comparison function. The second one will work on a different concept of identity, which is two arrays are identical if they have the same element, but not necessarily in the same order. So they have the same element, they have the same number of occurrence of each of those elements, but they are not necessarily in order. So this is closer to a definition of a set here, or the equality between arrays representing sets of values. Okay, so we're going to start by the first, int array compare by position. So let's go into whole.h, int array compare by position, int const int data1, const int data2, and then their size. Int size, and we are done. So let's cut and paste this, since we are going to go now save this file and then go in whole.c, where we are going to implement actually this function. And I'm going to go ahead real quick and while I'm at it, prepare the prototype for the compare by contents. And similarly, go in whole.c and prepare the definition of the compare by contents function. There we go, compare by position, which I modify into compare by contents. Okay, so we have all the code that we need here. We're going to return 0 here, just so that the compiler doesn't complain that there is no return value. So we have like the skeleton of the code that we need to implement for both of those functions. Let's get started with the easy one, the compare by position. Well, it's easy at the algorithmic level because we are going to take each element of each array in turn. I equals 0, I lesser than size, I plus plus. So we are going to iterate over both arrays in parallel. What happens if I find, sorry, that data1 index, data1 index I is different than data2 index I? Well, if I found this out, I can return 0. It's sufficient for only one of those to be different for me to be able to say those two arrays are different. If I reach the end of my loop and nothing is different, I return 1. So this is relatively simple, straightforward, and sensitive code here. Let's save. We're going to go to Conqueror and make sure that this is compiling okay. Compiles okay. Now we can just throw in a quick test here. We want to be able to compare two arrays, right? So let's take the time here to define array 1, which is 1, 2, 3, 4, 5, 6, and array 2, which is actually 1, 2, 3, 4, 5, 6 as well. Int 3 will be different, and it will be 0, 1, 2, 3, 4, 5. I'm defining just a couple of arrays here, just to play with to test different concepts of equality. These are going to allow me to test, for example, if my function realize that two arrays are identical. If it's the same array, like comparing the array 1 with the array 1, if it's different array, comparing the array 1 with the array 2, okay? Then we're going to try with arrays that are different. Then we will probably need down the road, and why not declaring it now, an array which is going to have the same element as another array, but in a different order. For example, 6, 5, 4, 3, 2, 1. This is a reverse of array named 2. And then I could even test, well, what if I have the same elements than another array, but I don't have the same number of each of them. Let me try to refine this example. Let's say I have an array that is containing 1, 1, 2, 2, 3, 3. This array has element 1, 2, 3. Now, this array here has also element 1, 2, 3, but in a different order. Finally, this array here has element 1, 1, 1, 2, 3, 3, which means it has element 1 to 3, but in a different order. Those arrays up to here are going to allow us to test easily our compare by position function. This array here, we will need them when we test our compare by contents function. So let's get started here. Printf, testing, compare by position function, \n. I'm going to actually put that before the definitions. And I'm going to run a couple of tests by hand. If int array compare by position of array 1 and array 1 of size 1, 2, 3, 4, 5, 6 is true. If this is true, 1 and 1 are correct. I have nothing to say. If this is not true, printf \t error comparing 1 and 1. It's a little bit cryptic, okay? A little more cryptic than I wish it would be, but let me try to get like some tests out of the way so that we can assess whether our code is correct. Then we will develop the second function. Then we will come back to those tests and try to straighten them up. If the comparison of 1 and 1 returns false, error comparing 1 and 1. And I'm going to run a couple of tests like that. So I'm going to compare 1 and 2. Result should be true. If the result is false, then I have a problem. Then I'm going to compare, let me cut and paste this one. I'm going to compare after that, well, let's see, I can compare 1 and 3. What do I expect here? I expect different. So if int array compare by position returns true, then this is a problem. After that, I'm going to compare 1 and 4. Is it really necessary, actually? No, it's not really necessary because this is a subcase of having a different array. It has the same numbers in it, but in a different order. So there is no bug I can think of that would actually lead to a positive result, except if the programmer who is implementing that function decided to get confused and implement a compare by contents as a compare by position. So, okay, never mind. I'm going to go ahead and test that as well, since normally I should not have a clue about how the function is implemented when I write those tests. So I'm going to do the comparison anyway. Should I expect true or false? Well, let's see. If I compare 1 and 4, I should expect a false in return. So if I get a true, then I have an error in my code. And I'm going to stop at that for now. And then we'll write, of course, more tests once we implement the other function. So Right now, let me see if I can get away with shortening also my test here. I'm not going to test the int array search function. I already tested it. I'm going to comment all of this. And I'm going to start by testing the compare by position function instead. As you can see, this commenting in and out is getting to be an old game. We're going to address that really soon, and we are going to improve a little our test function. For now, GCC, wow, a lot of problems here. Line 59, left-hand operator of comma expression has no effect. Well, let's have a look at line 59 inside of test.c. There we go. This is my initialization here that is posing a problem, and more specifically, this is an opening parenthesis that is causing a problem. So I'll fix that, save, and then I'm going to go back to Conquer. Compile again. Okay, couple of error left. Line 6 warning, unused variable by array. Yes, I commented the code that was using it. 5, 6, 7 are not used. These are warnings, so they do not prevent the compiler from generating an executable. I looked at those warnings. They are harmless for now. I will use those variables later. I execute. Testing compare by position function. Pretty good so far. Okay, no problem. I'm going to show back the code, and we are pretty much done with this first step of this exercise.